All right, students, this is a lesson on Module 1, Homework 1. I'm going to go ahead and now complete questions regarding to the homeworks. If you so desire, you can follow along with me by just going ahead and opening up your My Open Math and going ahead and completing the questions with me. Yours might be slightly different. It might be the exact same questions. However, if you have any questions, you're more than welcome to it. However, this is being recorded, and I would like to go ahead and continue it. I might take questions at the end of this session. So what you can do is flag your questions that you have questions on, and go ahead and let me know if you have any additional questions. All right, now I'm going to do the even problems. All right, question number 1 has been done. I'm going to do the even questions. So question 2. All right, so question 2 says negative 16x equals negative 32. Now, when a number is next to a variable, that's considered what we call a coefficient to the variable. And coefficients to the variable means multiplication is involved. The opposite of multiplication is division, so we're going to divide both sides by negative 16 to get negative 16 away from the x. So that eliminates them. So then that leaves me with x equals, and then I just carry it out. If I can't do it mentally, I can use a calculator. All right, you're more than welcome to it. However, negative 32 divided by negative 16 is positive 2. All right, and that is the answer that we're looking for. We're done with that question. And now I'm going to reveal the answer by showing you the answer key, which is right here. All right, now I'm going to complete question number 4. If you have questions on the odd questions, let me know for later purposes. You can always text me if you're having problems with the odd questions. So y over negative 2 plus 2 equals negative 1. Now, in order to do this, we need to isolate the y over negative 2 first. So that way, I'm going to go ahead and bring this over. Whenever I go ahead and circle a value and I bring it over to the other side, the equal sign, I'm going to switch its sign, and I can do this mentally. So if I take it and do it over there, and I imagine that this is all done mentally, I would go ahead and do negative 2 minus 2, which is going to be negative 3. So I go ahead and put negative 3 here, and I'm going to have y over negative 2. Now, in order to undo division, just like up here, this was undoing multiplication through division. To undo division, I have to use multiplication. So it's the opposite operations. So what I do to one side, I must do to the other. So I'm going to go ahead and multiply both sides by negative 2 in order to get y by itself. So then negative 3 times negative 2 is positive 6. All right, and that's the answer. All right, very simple. Good stuff. Number 6. All right, now 6x plus 6 equals 4x minus 1. So again, we're doing it algebraically. We're finding out what the value is. So we're going to go ahead and combine like terms by subtracting 4x from both sides. This would cancel this out, leaving us with 2x. I also simultaneously go ahead and since I'm adding 6, I would simultaneously subtract 6 from both sides as well. So I can go ahead and get negative 1 minus 6 is going to give us negative 7. And then since I'm multiplying, I would divide. And so my answer is going to be negative 7 over 2. Now you'll notice how it says enter your answer as an integer or as a reduced fraction. This would be a reduced fraction. It's already in its simplest form. So look at the answer and how it's presented. Negative 7 over 2. Now notice how this doesn't matter. This is the same thing as negative 7 over 2. Or you can also put it as 7 over negative 2. These are all the same thing. As long as you don't do, it's not this. This is wrong. -7 over -2. Because -7 over -2 is positive 7 over 2. And that is not the right answer. Okay? So be careful with that. So let's take a look at number 8. Now, since we're dealing with fractions, we always want to kill fractions as fast as possible. All right. And killing fractions means finding the LCD. Now, finding the LCD between 3, 3, and 6 would mean 6, because 6, 3 can go into 6 and 6 can go into 6. So what we'll do is multiply this side by 6 and multiply this side by 6. Now, notice how I do this. I'm going to do the distributive property. I multiply this times this. 3 goes into 6 2 times. 2 times 2 is 4. Likewise, 3 goes into 6 2 times, so 2 times 1 is 2. Now, notice how I do not distribute 6 to all the contents of that, just to the coefficient. That is a significant advantage of doing it before you do the distributive property, because then you only have to do it once. It's beautiful. All right, now I'll go ahead and do this, and that's going to give me 1, because 6 goes into 6 one time, and 1 times 1 is 1. Now I don't have any more fractions to deal with. I can do the distributive property now. So I'm going to get this. And then I'm going to go ahead and combine these like terms. And then I'm going to go ahead and subtract 6 from both sides. So I just did that mentally. All right, so that's going to be 6 subtracted from 1 is -5. And then I'm going to divide both sides by 2. And then that's going to give me that as an answer. Because remember, we want it in reduced form of its intended value. So that's why it's -5 over 2. That's using the division bar as a slant. All right, so now we have that answer. Okay, let's take a look at number 10. Now, number 10, you'll see this in PowerPoints that I give. Now, when we talk about consecutive integers, these are consecutive integers. 1, 2, 3, 4. Those are consecutive because they're one after the other. That's what consecutive means, to be one after the other. It looks like I'm having technical problems. Hold on for 1 second. Oh, there we go. Okay, now, so again, consecutive means one after the other. So what I'm going to do is think about it. It says give 4 consecutive odd integers. If the first integer is x, and I'm talking about odd, then let's talk about odd, for example. Odd would be, an example would be 23, 25, 27, and 29. Those are 4 consecutive odd integers. So what is actually happening? If I gave this value x, and it doesn't matter what the value is, to get to 25, I would have to go ahead and take that x value, whatever this is, and add 2 to it to get to the next one, right? Because 2 plus 23 is 25. Likewise, if I get to the third one, I would have to do x plus 4 to go from 23 to 27. Whatnot, because what is 4 plus 23? Now, to get to the next one after that, it would be x plus, and then add what to 23 to get to 29? And I would go ahead and add 6. So the idea they're looking for is to give any value of numbers that were given and generate a system of approach to solving for separate integers. And so that would be the answer we're looking for here is x plus 2, and then x plus 4, and then x plus 6. And it's always going to be that way for every single situation. Doesn't matter what the numbers are. For 4 consecutive odd integers, that is the system of approach to solving it. Likewise, the same thing applies to even integers. All right? You would do the same exact system for even integers because, again, if I do 22, 24, 26, and 28, think about what's needed to be added to 22 to get to 24, too. What do I have to add to 22 to get to 26? I have to add 4. What do I have to add to 22 to get to 28? And that's 6. So these are the same exact answers, no matter if it's even or odd. Now, simplifying that, I would go ahead and add up all my x's. So there's 1, 2, 3, 4 x's. And I would go ahead and add my constants together. So 2 plus 4 is 6. 6 plus 6 is 12. All right, and that would be the answer we're looking for here. All right, hold on. Let me see what the 2 plus 4, 6, 6 plus 6. That is okay. So they didn't ask to add them all together. They asked to simplify by adding the second and the fourth. So that's the 2 that they asked us to. I need to learn how to read. That's why it's good to check answers. Okay, so adding these together, it's going to be 1 plus 1, 1x plus 1x is 2x's. And then 2 plus 6 is 8. So that's why they got the 2x plus 8. So I assumed what they wanted was all of them added together. But that's false. This would be adding all of them together. Okay, simplifying the expression is what I was doing. All right. So now that would be number 10. Now, for the sake of learning how to utilize this, I will do number 11 for the fact that it's going to be helpful to you. All right, because this one's an odd concept for a lot of students. Students they struggle during this concept. So it says the sum of 3 consecutive integers is negative 60. So we're talking about the sum of 3 consecutive integers means one after the other. So it's going to be x, we don't know what the value is, plus x plus 1 because that would be the next consecutive integer. And then it would be x plus 2 because that would be the third consecutive integer. So that would be what we write for that. This is first, this is the second, and this is the third. We don't know what they are, but we do know that it equals negative 60. All right. It says list the numbers from smallest to largest. But before we do that, we need to know what x is. Once we find out what x is, we can then put x here, and then x plus 1, and then x plus 2. So x equals 3 x's. And then we have plus 3 equals negative 60. Subtracting 3 from both sides. We would get 3x equals negative 63. And then dividing both sides by 3, we would get x equals negative 21. All right. Now that we know it's 21, the next consecutive integer would be negative 20. And then the next one would be negative 19. Right? That's how you would write it. So it's asking us for the least amount. So it would be negative 21 first, and then negative 20, and then negative 19. So that's how consecutive integers work. So it doesn't matter if it's even or odd or anything. It's the same structure as long as you understand this approach. Since I did number 11, I'm going to skip over number 12 so I can get through it a little faster. All right. I'm going to start with I'm going to go ahead and do number 14. All right, number 14, we have solving the algebraic equation. It's asking us to, all right, let's just read this. It says, after solving the algebraic equation, blah, 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 all right, you end up with such. What does this mean? Now, anytime a system does not equal the same exact value after completing it, this is going to be no solution to the equation. All right, that's what we're looking for that answer, whenever it doesn't equal. I have a hand up.
I clicked it on accident. I apologize.
Oh, okay, no problem, no problem. All right, now, so that means no, there is no solution to the equation when they do not equal. If they are the same exact value, so if this was negative 42 equals negative 42, then that would mean all real numbers. All right, that's what that would mean. Okay, let's look at number 16. So I really, there's no work to be shown for number 14. So number 16, let me see. All right, this one, it says select all equations that have no solutions. Now, this one, it's going to take a little bit of time because the fact is you got to do each one of them. So what you want to do is you want to see if they don't equal to each other. So they're going to knock out. So let's take a look at this. So we're going to do these each individually. So I'm going to go ahead and do the distributive property. That's a 6, by the way, sorry. All right, and then I have the 10x. Now, when I add these two together, I'm going to get 10 for that value. And then when I go ahead and simplify this further, we can see that the 10x's are going to knock each other out, and we have 10 equals 8, and that is not a true statement. So this one has no solution. So that's one of them. Now we continue that. All right, we continue on with that by doing the same things for the other ones. So 7x minus 2 equals 5x plus 3 plus 2x minus 7. We're going to go ahead and combine these two together right here. All right, and that's going to give us 7x. And then we're going to combine these two together right here and get negative 4. And this has got a 7x right here. So the 7x's are going to cancel each other. So negative 2 equals negative 4 is not a true statement. So that one's going to be also not have a solution. Now, all we're doing is seeing if these two match. If they match, then it's all solutions. If they don't match, then it's no solution. So that's how simple this is. But it's a matter of understanding how to combine like terms and such. So we have this. I'm doing the distributive property right now. And now when I go ahead and combine these together, I'm going to get 4x plus 12 equals 4x plus 12. Well, that's exactly the same exact problem, same equation. So it's all solutions. So no matter what you put into this one, it's going to equal the same thing as that one because it's the same exact equation. Therefore, this one is all real numbers. We're not going to click on that one because that's not no solution. Now we're going to go ahead and do the last one. We're going to do distributive property while writing it down. So it's 12x minus 10 equals, and then combine like terms, we're going to get 2x plus 6x is 8x's minus 10. Now, it doesn't matter about these. These will cancel each other, but this will equal 0 because when you go ahead and bring this together, then you're going to get 12 minus 8 is 4. And then that's 4x, excuse me. And then you're going to get 0. Well, you're going to get the value of x equals 0 for this because 0 divided by 4 is 0. So therefore, this one doesn't result as negative, or excuse me, as no solution. Okay, so that's how that works. I have a question, I think. Let me see, everybody. Oh, you can't see what I'm doing? Oh. Thanks. I appreciate that. Sorry about that. Thank you. So there's my work. Okay, so this one doesn't work. All right, as far as giving those solutions. So the answers are the two that are provided, this one and this one. I thank you guys for doing that. I get so involved in explaining things to you that I tend to forget to move the paper. All right. Well, so that's number 16. So that one's a little tedious in that you have to do all of them. All right. So I I understand if you're facing with frustration at times. All right. So let's take a look at number 18. All right, so now we're dealing with just word problems. And sometimes word problems can get really intimidating for students. I can understand that. But again, I'd like you to try to, do your best with them, okay? After eating at a restaurant, let me go ahead and write number 18. After eating at a restaurant, your meal came to $37, including tax. You decided to give a 15% tip, adding it to the total meal cost. So it says let M equal the meal cost. All right. Write an equation you would use to solve this problem. So the total meal cost, so you can put it as TMC equals, all right, and then it's the meal cost, which is $37. All right. So we got $37, but it says your meal came to $37, including tax. So it's going to be total meal cost is equal to whatever the meal cost is. Let me do this, including tax. So it's $37, 15% added to the total meal cost. Okay. So total meal cost. That this is going to be what we represent the total meal cost. Um, are they not? Is that not in the frame? I mean, that looks like it's in the frame. Okay, it looks like it to me. I'm seeing it on yours. Anyway, so we're looking at the total meal cost. It is. All right, good. Is 15%, okay, the total meal cost is 15% of the meal cost equals M. Now, although we do know what the meal cost is because we have the 37, they're asking for the value of whatever the meal cost is without knowing that it's $37. So when we have $37, we put the $37 into this particular equation. So we would go ahead and put in the TMC, the total meal cost is equal to the meal cost times the percentage plus the whatever the meal cost is. Then you go ahead and put in the value of the $37 in at this time. So this is why you go ahead and do this. So you could take your calculators, all right? You can take a calculator and do 0.15 times the 37 and get $5.55 plus the $37. And that's where the 42.55 comes from. So that you use a calculator at this time. That's why it's important that you have a calculator. All right. So you have this. Is there any questions on how this came to be? Again, if you have any questions, you can go ahead and text me or email me. Okay, no problems. All right, so now 20. It says convert 20 degrees Fahrenheit to degrees Celsius. Now, what I'm going to do for you is give you an easier approach without fractions to things dealing with temperature. So Fahrenheit is equal to 1.8 Celsius plus 32. This one's a little easier than dealing with the fact that you have 9/5. Now, in order to get Celsius by itself, we would go ahead and take Fahrenheit and subtract the 32 So Fahrenheit minus the 32. And then we would divide it by the 1.8. So I'm giving you now the way you solve for Celsius if we needed Celsius. So it says convert 20 degrees Fahrenheit, okay, 20 degrees Fahrenheit to Celsius. Now, if we need the value of 20 degrees Fahrenheit and we need to convert it to Celsius, we're going to need to go ahead and utilize this particular equation. So we're going to take the value of Fahrenheit, which is 20 degrees, and minus 32 from it, and then divide that by 1.8 and get negative 6.6 degrees Celsius. And it says to round to 2 decimal places. So that's going to be equal to, or approximately equal to, negative 6.67 degrees Celsius. And so there is the answer that we're looking for. Okay, right here. All right, and it is what we have here. So these two formulas right here, very important to you. It's a lot easier to handle Celsius conversion and Fahrenheit conversions. All right, 22. We have 3 more minutes of class. Okay, a high-speed boat travels from the mainland to an island 231 miles away in 3.5 hours. What is the boat's average speed? If necessary, round to 2 decimal places. So the speed rate distance is equal to rate times time, by the way. So this says that the distance is 230 miles away. And the rate is what we're looking for is the speed. So it's the time is 3.5 hours, and the rate is what we're looking for. So we can convert the 1/2 to 0.5 and just simply divide both sides by 3.5, and we're done. That's the answer we're looking for. So take your calculators, do 230 divided by 3.5. I'm losing light, so here. Let me do that. So 230 divided by 3.5, and we get right here 805. I can't believe that that's possible. No way. 230. Did I mess something up? No, that's not possible. How? Oh God, that is impossible. Yeah, what? 3.5 hours. Thank you. I did multiply. I love you. Who's that? That's awesome. Ryan, you're the man, dude. I was like, that's impossible. You're right. I did multiply. Damn. I was like, that's impossible. I like it. Ryan, you've earned a gold star today. All right. You know what? Now there are 3 more questions left. Um, I do want to do 24. Bear with me. I want to make sure I get through all of these. So y equals, and these are called literal equations. And you have to get x by itself. So what you do to get x by itself is first, you want to go ahead and multiply by the denominator to both sides. So that way you can get that out of the denominator. All right. So you're going to go ahead and get 2x, or 2 minus x times y equals 5. And then we're going to go ahead and divide both sides by y to get the y away from this grouping. So I have that now. I'm going to go ahead and then I'm going to go ahead and subtract the 2 from both sides. Because I'm trying to isolate the x, get the x by itself. But because this is negative, I want to switch the signs to everything. I'm falling off that frame almost, guys. So I have this as the answer. Now there's multiple ways of writing that answer. I could write it where I write it also like this, where I have -5 plus 2y all over y. There's a couple ways you can write it. Here is what they provided, and it is what, in fact, I gave as the second answer. Okay, and I fell off the frame. I get it. There it is. Okay, so we have number 24 complete. Okay, so I'm now going to go ahead and stop the recording for this lesson.